Good morning. Today's problem is lowest common ancestor of a binary tree. Now for this problem, I unfortunately couldn't do the in progress code. I'm proud of my solution, but there was a lot of hemming and hawing at the beginning of the video which didn't make for good watching, so I'm just going to go over the solution now. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition on Wikipedia, the lowest common ancestor is defined by two nodes, P and Q, as the lowest node in the tree that has both P and Q as descendants. We allow a node to be a descendant of itself. So in this tree, the common ancestor of 5 and 1 is 3. In this tree, the common ancestor of 5 and 4 is 5. So one thing that I noticed right away is all node values are unique. That is very helpful. It lets me compare nodes by value to find their position in the tree, rather than having to somehow comprehend the whole tree. So, looking over at my solution, I created a helper function that does a depth first search. First, if node is none, we return false. Then we append the current node to an in progress path list. If the val that we're searching for is equal to the current node's value, we return true. And then we recursively call on the left and the right nodes. Whenever we find the node we're looking for, we're going to return true, marking that we found it. So if this call finds the node, then it comes back as true, and then we end recursion returning true. Same thing for the check on the right. If we didn't find the node in either of those branches, then we're going to pop off the current node and return false. This is a dead branch, get us out of here. Okay, then in the main function, we create two lists, the P path and the Q path, and then call that helper function on both. Which means after this part, we have a path from root to P and a path from root to Q. Now those two paths are identical up to the point of the least common ancestor. So least common ancestor equals none, and then we're going to iterate through both paths, and as soon as we find a divergence, or if one of those paths ends, the loop is going to end and LCA will be equal to the last identical node. So we return LCA. And that did it. And my first solution beat 97% in runtime. So I'm pretty happy with it. Thanks for joining me.